So this video marks the beginning of previewing trig identities. We will continue to go back and forth between Unit 4 and Unit 5, but this is the first set of identities that you will need to know while solving trig equations. And quite honestly, these identities are very straightforward and easy for you to recognize. So to begin with, we have our reciprocal identities, which are in the red box. And then we have our quotient identities, which are in the blue box. So thinking back to geometry and even algebra 2, we're very familiar with these relationships. We know that sine is equal to 1 over cosecant. We know that cosine is equal to 1 over secant. And we know that tangent is equal to 1 over cotangent. So of course, the opposite would also be true. And then again, for our quotient identities, we know the relationship between tangent, sine, and cosine. So if we know this relationship, if we flip it over, that gives us cotangent because they're reciprocals of one another. So there's always one goal in mind whenever solving trig equations. It's to simplify. We want to take what's given to us and we want to make it much smaller. So when using reciprocal and quotient identities, the first step to solving any problem is making sure the only thing that you have on your paper is cosines and sines. So if we look at this problem right here, this says cotangent times secant. Well, I don't see any cosines or sines. What I need to do is I need to rewrite this as cosines and sines. So I went ahead and rewrote this. I know that cotangent, according to my quotient identity, is equal to cosine over sine. So I rewrote that right here. And I know that secant, according to my reciprocal identities, is equal to 1 over cosine. So now I went from having no cosines and sines to only having cosines and sines. So here we have two fractions being multiplied by each other, and we know that when you're multiplying fractions, you don't have to worry about the denominator. So let's go ahead and multiply these out. This is going to give me cosine of theta all over sine of theta cosine of theta. So now very quickly, I should see that there is a cosine on the top and a cosine on the bottom, so we can cancel that. And this simply just leaves me with 1 over sine of theta. Now, to finish off this problem, if I look at 1 over sine of theta, I should recognize that this is a reciprocal identity and that 1 over sine of theta is actually equal to cosecant. So my final answer here is simply going to be cosecant of theta. So I took this equation right here, cotangent of theta times secant of theta, and by using my reciprocal and quotient identities, I was able to simplify it down to cosecant of theta. So now let's try this again with another problem. Here I have sine of theta divided by tangent of theta. So in my numerator, I don't need to do anything because I already have a sine. But in my denominator, I have tangent. And again, we always want to convert everything in the problem to only sines and only cosines. So if I take a look at tangent, I know using my quotient identity that tangent is actually equal to sine over cosine. So I rewrote the problem. Again, the numerator didn't change because sine is something that we want, but I changed my denominator using my quotient identity, so now I have sine over cosine. So here we have a 3-story fraction, and what we need to very, very quickly recognize is that with a 3-story fraction, we should be doing keep, change, flip. So people oftentimes get confused with what is the numerator and what is the denominator. So you always refer back to your original fraction. So sine of theta is the only thing in my numerator. So this is my first fraction. And tangent of theta is the only thing in my denominator. So this is my second fraction. So when I set up keep, change, flip, I want to set it up as sine of theta over 1 is my first fraction. I'm going to change to multiplication, and then I want to flip the denominator. So the denominator is sine over cosine, but when I flip it, it's going to become cosine theta over sine theta. And now again, before we even multiply this, we notice that there's a sign in the numerator, there's a sign in the denominator over here. So both of these can cancel, leaving me with cosine over 1, or more simply just cosine of theta. So again, we did the same exact thing we did in the previous problem. We took something that was slightly more complex and we simplified it down to a single trig expression. So you're gonna do this for 2 problems, and then following this video, there's gonna be another video over Pythagorean identities, and that's when things get a little bit more complicated. But if you take this step by step, you'll be able to pick it up very quickly.